Researchers propose a new structure to harvest untapped source of fresh water. An almost limitless supply of fresh water exists in the form of water vapor above the Earth's ocean, yet remains untapped. A new study from the University of Urbana-Champaign is the first to suggest an investment in a new infrastructure capable of harvesting oceanic water vapor as a solution to limited supplies of fresh water in various locations around the world. The study, led by a civil and environmental engineering professor and Rair Research Institute Executive Director Praveen Kumar, evaluated 14 water-stressed locations across the globe for the feasibility of the hypothetical structure capable of capturing water vapor from above the ocean and condensing it into fresh water, and do so in a manner that will remain feasible in the face of continued climate change. Kumar also said that the water scarcity is a global problem and hits close to the home here in the United States. Regarding the sinking water levels in the Colorado River Basin, which affects the whole western United States, Kumar also said, however, in the subtropical regions like the western United States, nearby oceans are continuously evaporating water because there is enough solar radiation due to the very little cloud coverage throughout the year. The researchers also said previous wastewater recycling and cloud seeding and desalination techniques have met only limited success. Though deployed in some areas across the globe, desalination plants face sustainability issues because of the brine and heavy metal-laden waste water produced, so much so that California has recently rejected measures to add new desalination plants. Kumar also said that we will need to find a way to increase the supply of fresh water as a conservation and recycled water from existing sources, albeit essential, will not be sufficient to meet human needs. We think our newly proposed method can do that at large scales. The researchers performed atmospheric and economic analysis of the placement of a hypothetical offshore structures 210 meters in width and 100 meters in height. Through their analysis, the researchers concluded that the capturing moisture over ocean surfaces is feasible for many water-stressed regions worldwide. The estimated water yield of the proposed structures could provide fresh water for large population centers in the subtropics. The atmospheric science professor Domingos also said one of the more robust projections of climate change is that the dry regions will get drier and wet areas will get wetter. The current regions experiencing water scarcity will likely be even drier in the future, exacerbating the problem. And unfortunately, people continue moving to water-limited areas like the southwestern United States. However, this projection of increasingly arid conditions favors the new ocean vapor harvesting technology. Also, Afifur Rahman, a student in a university, said that the climate projections show that the oceanic vapor flux will only increase over time, providing even a more freshwater supply. So the idea we are proposing will be feasible under climate change. This provides a much needed and effective approach for adaptation to climate change, particularly the vulnerable population living in arid and semi-arid regions of the world. The researchers said one of the more elegant features of the proposed solution is that it works like a natural water cycle. The researchers also said that the only difference is that we can guide where the evaporated water from the ocean goes. Also, they said this study opens the door for novel infrastructure investments that can effectively address the increasing global scarcity of fresh water.